Hello, welcome to our next episode of Kubernetes Happy Hour. Today we're going to be tackling something that's a little practical, namely how to route traffic between our services that may be distributed throughout the world. So I'm going to go through an example today. I'm going to set up a service and I'm going to show you how to set up Ingress using nginx, tied with external DNS controller, which is a application that interfaces between your Ingress and Route 53. So it scrapes your ingresses or services or deployments or endpoints and figures out what the hosts are and updates them in Route 53. And this is in combination with Certificate Manager, which will go out and generate a certificate for the hosts that are in your nginx Ingress. And then I'll show you how to set up the geographical distribution of the API calls, like how to handle the Ingress. We're going to use Route 53 weighted records to do that. I'm going to show you what's automated. I'm going to show you what's not automated, where there's a really big opportunity for somebody to step in and write a project for this to automate the part that I'm going to show you that's not automated. Why we're doing this is because we could do things like blue-green deployments. We could say like we can route all traffic away from a certain region into another region, giving us the ability to update that region where the traffic's been turned away from, bring it back up, and then have the ability to do canary testing in that new region with the new code base. That's really what it's used for. It's also used for if you lose a region, right, and you want to direct traffic to the other region. So both deployments and for failure handling is why we want to set this up. So surprisingly, there's not a lot of automated solutions for this out there. I haven't seen one. But what we're going to do is, at a high level, I'm going to walk through, I'm going to describe the Ingress, how to set that up. What we're going to do is we're going to create local entries inside Route 53. And then we're going to have another layer of an entry in Route 53 that is going to be the geographical entry. And that's not controlled by the external DNS controller. That will be controlled by the human operator for now, because it's not automated. What will be automated will be the local records for external DNS, which point to the local load balancers inside Amazon for that region. And then on top of that, we're going to build another layer, which is the human manual part of it, where we're going to set up the weights and where to go for traffic coming into our APIs. And when we give a endpoint to our clients to talk to our API, we're going to be giving them the high-level endpoint for them to talk to. So let's dive into it. I don't think this should take about like 30 minutes. And the idea behind this is I want to share this with people I work with to know that there is a way to do geographical load balancing if you're using Kubernetes. Even if you're not using Kubernetes. If you're not using Kubernetes, you can do the same thing, what I'm doing, but it's all going to be manual. So it's kind of going to be a pain in the neck. The one I'm going to show you, there's a manual part of it, but usually you don't have to update the manual part of it unless you are redirecting traffic because of failure or you want to actually do that blue-green deployment. The automated part of it is, what I'm going to show you is bringing up and bringing down services behind a local load balancer. That all happens automatically. And the services behind that load balancer, those all get configured automatically by Kubernetes. And the tie-in from the Route 53 entry to the local load balancer is also happening automatically. So all the core integration parts with Amazon are happening automatically. So if you wanted to do this outside of Kubernetes, it would require a lot of manual work. So I'll get into that. So I'll show you guys. So the first thing I'm going to do is going to show you an Ingress. So the Ingress is going to be is our basic way of describing how traffic is going to be handled coming into our service. So I've done Kubernetes happy hours before in the past about Kubernetes ingresses. So what we're going to want to do here is show you my Ingress here, right? So Kubernetes has a command kubectl get ing, short for Ingress. And these are our two ingresses. So I picked this IMS service. It's just something I've been working on recently. and I set it up to handle geographical API handling of the Ingress traffic coming in, handle it through Route 53 geographical weighted records. So you can see I have two ingresses here. Let me make this bigger for you guys. I have two ingresses here. So the first one is going to be our global one that we hand out to our clients, right? This is what we're going to tell our clients to talk to. You can see it points to the same load balancer here. So this is happening for us automatically. So when I define an ingress, I'll show you guys some more detail about the ingress. When I define an ingress, it will automatically use a load balancer that's being published by the ingress controller. So this is an nginx ingress controller. So let's do some more detail, get that ingress and give me the YAML output on it, right? So this is the global one. You can see this is the typical ingress definition here. This is built into Kubernetes. We're going to say use the ingress controller for internal nginx. So we have an nginx controller running that's listening for ingresses to be created with this class. So if the ingress controller for nginx sees this class in the annotation, it will implement the ingress inside nginx. And nginx already has a load balancer, so that load balancer points to nginx, and then nginx will handle the routing of the traffic. So that's how that works. So we have a host here. This is the global host here. And you can see that it forwards to our service. This is what our service is going to be. So that's our IMS service. That's where actually our pods are running, right? So again, a service is a way to access your pods that are running inside your Kubernetes cluster. Some TLS definitions here, not really important, just the fact that this will be hosted. This IMS, that container.dev.module.org, will be hosted by a cert that's defined here in this secret. So that'll be the cert that will power the HTTPS portion of this service. And then you can see here, this is our load balancer here. So the load balancer is the one that gets used by the ingress. So let me see, you can see this load balancer is going to be the same as the other one. If I change this to regional, and that's because the reason why it's reusing the same load balancer is because it's the nginx controller is handling both of these ingresses, and this is the load balancer for nginx. So really what this solves too, if it's not so obvious, nginx ingress controller is you can have a handful of load balancers serving all your traffic. You don't need one load balancer per traffic. So now you can do host-based routing using an ELB or NLB inside Amazon. Something recently is Amazon just released NLBs for the load balancer type in Kubernetes. So there's annotations to set that up, but I'm not using them yet, so I can't really talk about that. So maybe that's something I want to talk about in a future Kubernetes happy hour, but right now I'm using ELBs. So let me go back here. So okay, so I got these two ingresses, right, and they're implemented and they're inside nginx. So let me do the ingress thing here. You can see that the reason why I know they've been implemented is because they're actually using the load balancer address for their address. So this load balancer serves on port 80 and 443. So requests that come into port 80 will get forwarded to 443 or redirected to 443. So our service is really, the only way to get to our services is through TLS. And we have TLS 1.2 enabled. So we're using a Let's Encrypt cert. So this this wildcard cert is actually a Let's Encrypt cert. So we use a wildcard cert, so Let's Encrypt lets you do that. So pretty much we don't have to regenerate a cert per service, so we could just have to manage the wildcard cert. So Kubernetes has something called the cert manager, which is managing the renewal and the issuing or the removal of our certs. So it's something we don't have to worry about anymore. So certs are automatically updated or renewed via the certificate manager. So I've gone over that before in the past Kubernetes happy hour. So let's stay on point. let's continue trudging forward with Ingress. So I got these two Ingresses, and this is the local ones. I call this regional. You can see that this is IMS.VA0, so this means like the Virginia geography for this Ingress, right? So what this means is like this guy, at a high level, what I'm going to do is I'm going to have this guy point to this guy. And I'm going to have this guy point to this guy through a weighted record. And then I'm going to have another entry for this guy that also points to another region for, say, Oregon, right? And so I would change this VA to an OR0. And then that would have another weight added to it. Okay, so an important thing to know here is, we have two clusters, one in Virginia, one in Oregon. Each one has a external DNS controller running in it that's managing DNS entries in the same hosted zone. So you want to avoid the scenario where you have an external DNS controller, say in Virginia, that's managing a resource record in a hosted zone, and you don't want to have the Oregon version of the external DNS control also managing the same resource record, because it's undefined. You don't know what's going to happen. It's really a race to see who gets there first, I think, is what would happen, because when external DNS goes into Route 53 and it makes the entry for the resource record, it puts a TXT record in there. And that TXT record has ownership. It says, I own this record. No other external DNS owns this. But the issue with that is you don't know which one gets there first. So it's kind of like an undefined scenario. It's not deterministic about what the behavior is going to be. So we did a little trick to say that only manage the records that are marked with a special annotation. So external DNS is running with a configuration option, which is the annotation list. And this annotation list is a special marker to say if the Ingress has this special annotation, then this local external DNS controller can control it. So let me show you what that is. We go into that's on the regional settings. And the other reason why we want to do that is because that global one, it'll appear, that Ingress will appear on both the East Coast and the West Coast, right? So we don't want external DNS managing that one because, like I said before, it would not be deterministic about which one would own it first. And I think you'll run into race conditions in the future. It'll just be a debugging nightmare. So what we've done is we've added this annotation to the external DNS controller to say only manage records that have a special annotation on it. And you'll see that on the global DNS record, it will not have that annotation. So external DNS will skip over that one. So let me show you that to you. And the reason I'm maybe showing you guys this will clear things up. So here's the regional one. The regional one will have an annotation up top that we made called Vonage.io DNS classes external. So anything that has this annotation means that the external DNS controller can control it. And if you saw on the other one, not the regional one, the external one, it didn't have that annotation. So if you go up here, it only had this one annotation here. So let me show you here. Make sure you guys can see this. Okay. Let me go to kube system. I'll show you how the pod gets configured. Kubectl get pods, or yeah, get deployments. And grep on external. There should be this guy here. This is what I set up. This global external DNS entry. Okay. So this is the external DNS controller. So let's do a get on that deployment. You can see how I configured it. I'll show you how the annotation list gets passed in. Okay, so this is the startup here. You can see that here it is, the annotation filter. So when you add this annotation filter, that means that this external DNS controller will only operate on ingresses that have this special annotation. So it's like a filter for, yeah, that's what it is, for the ingresses that come in. And it says run with a, let's see, it's saying get things from services, get hosts from services, and get hosts from ingresses. Okay. All right. So hopefully that clears that up. So let's go into Route 53 and I can show you like what happens, what the external DNS controller makes in Route 53, what it doesn't make, and how to set up the weighted records. Okay. So let me go to my browser. Okay. So I have this set up already. Okay. So this is the hosted zone. You can see the IMS is in here. You can see that, let me filter on IMS so it can be obvious. So, okay, we got 6 records. 2 of them are TXT records. You have one in Virginia and one in Oregon. So this is the one in Oregon. This is the TXT record I was talking about. And then there's a signature stamp inside the TXT record to say which external DNS controller owns the record for the A record. Okay, so you can see that this A record points to our load balancer for the local nginx ingress. Okay, so if I went to ims.oregon 0, it would actually go directly to the local installation, which would forward to the local load balancer in Oregon. If I went to ims.virginia, it would forward to the load balancer that is in Virginia. So this load balancer is going to be different than that load balancer. Yep, and that's true. And you can see this TXT record, which is Virginia, shows that it's owned by the Virginia DNS external controller. And this one in Oregon is owned by the Oregon one. Okay, great. So, and then, so you got this set up. You got ways to get directly to the regions, Oregon and Virginia, right? And this all happens automatically. So this part is all automated. So as of right now, anytime we add a pod, remove a pod, something goes down, something comes up, it all gets handled magically by Kubernetes Service Discovery. Updating the load balancer, if the load balancer goes kaplooey and needs to create a new one, that all gets updated automatically as well. So everything's automatic at this point. What I'm going to show you going forward from this point is not automated. This is really where I think somebody could step in and design something. I was hoping like we had an intern or something. It would be a great intern program to do this, to automate what I'm about to show you, because I would like to not have to do this manually. I just don't have the time to start a project to do this yet. I just got too much going on. And I think it's a good opportunity for somebody to get in here and learn and get their feet wet with automating some DevOps procedures. So let's go into here. This is the part that's not automated. This is what I'm going to show you. Okay, so let's go back to the terminal. So you guys can see my terminal. So you got these two guys, these two entries here. They are the global DNS entries, like I showed you before in the Ingress, which was IMS without the region, just ims.container. And this one is also ims.container. And what these guys are A records that forward directly to the regional hosted zone entry. So the reason why I want to do this is because A record traffic routing in the same hosted zone is free. So Amazon doesn't charge you for that. If you use like a CNOM, I think they charge you for that. Okay, so you want to use a record, keep it all within the same hosted zone. So your A record DNS lookups are free. Okay, and what you do down here is so yeah, you're going to drop down here and you say yes, it's alias, it's an A record. You pick it from the list here. And in this current list, there's within the same hosted zone, there's Oregon. Okay, and what we want to do is we can set a weight. We can say, give it an ID, which is like this unique identifier, and give it a weight. A weight can be 0 to 255, and what that weight will do is give it the priority. So that's a priority measurement of how the traffic should be shaped. So what it does is for record sets that have the same hosted entry name, so I have two, which are ims.container.ws dev.bondage.networks.net, it will add the two together. And so if I have one in a weighted record of 1 in one entry and a weighted record of 0 in another, all the traffic will go to the one with 1 because it adds up 1 and 0, and 1 out of 1 is all the traffic. So if you had, say, 1 and 1, that would be a 50-50 split because 1 plus 1 is 2, and each one would be 1 out of 2. So it would split things 50-50 like that. If you had one marked as 255 and the other one marked as 1, one would get 1/256 of the traffic, and the other one would get 255 out of 256 of the traffic. So I think that's the highest level of granularity you can do, 0 to 255. So if you did, if you put like 2 and 2, or 2 and 1, 2 and 1 would be 2/3 will go to 1, 1/3 will go to the other. If you set them both to 0, it does an even split. It's smart like that. It doesn't let you do that into text. That's like kind of a bad case, and it defaults to 50-50. If you set 0 and a number greater than 0 between 0 and 255 on the other one, all the traffic goes to the other one. So that's what I did here. I set all the traffic going to the other one. So this is the part that's not automated. So let me go back here. So here is 0, which is Oregon. So which means that no traffic is going to Oregon because I have a 1 going to Virginia, which means 100% of the traffic goes to Virginia. 0% of the traffic goes to Oregon. So if I wanted to switch my clients to send all traffic to Oregon, a couple of things need to happen. I need to update the 0 to a 1 on Oregon and update the 1 to a 0 on Virginia. That's the easy part. The hard part is your clients. Your clients need, since this is DNS, they need to have an expiration time on their DNS query. So that's very important. Usually, typically, it's like a 60-second. I have in this DNS record, there's a 60-second time to live. But some clients will not go back and re-look up the name, the DNS name for given a URL. So you have to make sure that your clients all will refresh their lookups that have an expiration on their time to lookup, especially Java clients. Java ships out of the box, doesn't have an expiration on DNS lookups. So you want to make sure your clients have expiration on DNS lookups. We're also continuing to go to the region happily because once they do that first lookup, they get the IP address, and the IP address would be the IP address of the load balancer within that region. It would use that happily going forward until it couldn't. So you want to have the clients have an expiration time. So let's go back to here. Okay. So I think the expiration time is set on here. One thing I wanted to show you that there's a setting here to evaluate the target health. You should always click out the yes because that will allow you to detect when the load balancer is down and will help you route your traffic. Like for instance, if Virginia goes down, like for instance here, I guess what this would do would be if I had this set up where I had like this was 1, Oregon was 1, and Virginia was 1, and then Virginia went down, then all the traffic would go to Oregon automatically. So that's kind of a neat thing. If you wanted to be in that, if you're equipped to handle that, like if you can handle 50% of your traffic going to one region and 50% going to the other region, and one region goes bam, you can have automatic failover to the other region without having manual intervention. As long as you have the same weighted record for both regions. But how I have this set up, I have all going to one and none going to the other. So somebody needs to step in and switch it up when there's a need to switch the traffic over to the other side. So this is the part that needs to be automated. So what I envision is either a CRD where you can come in and you can say, these are the weighted records that I want for this hosted zone, this record set in this hosted zone, and this is the weight that I want, and it should tie to the regional entry in the hosted zone. So what I'm setting up here, because I set those global things up myself manually, what I would hope for is to reflect the information you need inside the CRD, and there would be a controller that would be running that would read that and then update the appropriate entries. So you would have a controller running in both regions, and that controller would only create the weighted record for the region that it cares about, the region that it is within. It wouldn't create the weighted record for the other region, because it would be the other controller running in the other region that would control that. So that's what kind of I envision. And the tricky part is to get the controller to only operate on the weighted record that it needs to operate on. So you don't have this race condition. So that's I thought that would be a pretty cool project, because it would expose junior people to CRDs, the controller or the operator paradigm. You can use the operator framework from CoreOS to set that up, and it would expose people to how to integrate with Amazon Route 53, how to set up weighted records and all that, and best practices and all that stuff that comes along with it. So that is manual for right now. So that's really how to do it. So let me show you what goes on from the command line. Okay, so if I do a dig, right? If I do a dig on ims.container.dev.manage.networks, okay, you can see that obviously this is going to Amazon, and it's got 3 records coming back, because the reason why it's got 3 records coming back is because our Kubernetes cluster is deployed in 3 subnets, using 3 subnets inside East Coast. And whenever you create a load balancer, it takes an IP address from each one of those 3 subnets to have for high availability. So if you lose one of your subnets or one of your local data centers inside Amazon, the other 2 will take over. So that's why there's 3. Okay. So right now you can see that this 10.203, that's actually going to Virginia. So what we're seeing here is the traffic all the time is going to Virginia. So let me do an experiment so you guys can see this. Okay, and let me set this up 1-on-1. So I'm going to go in here. So Virginia is already set to 1, so let me update this one to 1. Okay. Okay, so now they're both 1. So this one is 1, and this one is 1. So you can see like 50% of the traffic is going to go to 1, and 50% of the traffic is going to go to the other one. So let me do a dig. So depending upon how long this takes, this is 10.203. So when this changes to 10. something else, it's not 10.203, it'll be going to Oregon. So we'll have to let the expiration time kick in. And while that's doing that, I'll talk to you about what we're going to talk about next week. So this week is something super practical. It's really meant for people I work with to take a look at it, to figure out if they want to use this technique to do geographical load balancing of their API requests. I think there's a lot of opportunity here. So besides doing blue-green deployments, and besides handling complete catastrophic failure of your sites in a region, this is a good way of semi-automating your traffic pattern shaping. So let's go back here. Let me see if it's updated yet. Ah, it is. So, okay. So let me go back here. You can see my local term. So now you can see 10.206. So this is Oregon. The 10.203 is, there's 10.206, 10.206, 10.203, there it is. So you got some of the traffic going to Oregon, some of the traffic going to Virginia. There's 10.203, 10.2, so it's switching back and forth. Okay. So this is really a nifty trick to implement your own kind of like global load balancing without having to use expensive hardware. You know, you can do it through software. So that's kind of it. I figured it would take about a half hour. It's about a half hour. Hopefully this was informative for you guys. Next week, I will try to do kubeless. So if I have time to open it up and do some experimentation with it, I'll do kubeless. Because last week I did OpenFast. This week I want to do something a little bit more practical. Next week I'll do kubeless. We don't actually run kubeless, so this is really just a R&D experiment for myself to see what the differences are between kubeless and OpenFast. Since I delved into OpenFast last week, I have that context still, while it's still fresh in my mind. And I'll run kubeless, and I'll be able to compare and contrast the two and see whether one does something better than the other one. So kubeless is yet again another functional programming or functional FAS kind of architecture where you can deploy your functions as containers, true microservices inside a Kubernetes cluster. And then you get everything that comes along with it, including the scheduler and controller manager and service discovery and all that good stuff. So hopefully I'll see you guys next week. Have a great weekend. I'll talk to you later. Bye.